This video is intended to help you understand the notes for solving inequalities. Let's get started. First, let's do what we always do and recall some things that we already know. So we remember those rules for multiplying with positives and negatives. We've been doing them all year. We know that a negative times a negative gives us a positive, and a positive times a positive also gives us a positive. But if we mix it up and only have one negative, so one negative and a positive or positive and a negative, that's going to give us a negative value. So that's all review. And we know that an equation, it sets two things equal. Two things are equal. Equation, they're going to have an equal sign. And an inequality means that they are just related. Two things that are related, but they're not necessarily equal. They might be greater than or less than, greater than or equal to, or less than or equal to. And if you are having a hard time remembering those things, go back again and look at our last lesson on graphing inequalities, and that should help you. A solution is a value for the variable, a value, but it's a very specific value. It's a value that makes the statement true. A value that makes the statement true. And inverse operations. Well, we know that that is how we undo when we're solving. For example, if we want to undo multiplication, we're going to use division. And if we want to undo division, we're going to use multiplication. In the same way, if we want to undo addition, well, we're just going to use subtraction. And if we want to undo that subtraction, we will use addition. So it's that inverse relationship. So how do we use operations? How can we use operations when solving an inequality? Let's first think about how do we use inverse operations to solve an equality. Not an inequality, but an equality. So let's see, we worked with the example 2x equals 6 earlier in our last lesson. And we saw that, well, right now that 2 is attached to the x by multiplication, so I'm going to use division. I'm going to divide by 2. On what I do to one side, I have to do to the other. I'm going to carry down that equal sign so that on the left side, 2x divided by 2, well, those just turn into a 1, which gives us one single copy of x on the left, and 6 divided by 2, that gives us 3. So we just saw that we just use whatever operation is being applied to the variable, and we do the inverse of that to basically undo it, or to get a single copy of x alone on one side, which is always our goal when solving. Okay? So how could we use that with an inequality? Well, we're basically going to be able to do pretty much the same thing. So let's look if we had 2x, let's say if this time it was greater than 6. Well, we're still trying to find that value, the focus value that tells us, well, we'd know if it's greater if we knew what it was going to be equal to. So let's go ahead and use the same logic. It's applied by multiplication, so let's divide. And that again gives us x over here and 3 over here. But we're just going to, this time, instead of carrying down an equal sign, we're going to carry down that inequality symbol. So now I'm saying, well, x has to be greater than 3. And we can always check that by saying, well, let's say, what if it's 4? Would 4 work? Would 2 times 4, would that be greater than 6? Let's see, 2 times 4 is 8. On the right side I have 6. Is that greater? It is greater, so I know I'm right because I tested that, okay? I evaluated it in with a greater value. So basically, in most cases, we're able to treat it the same way we would an equation and just make sure that we follow down with that symbol to make sure everything stays in balance. What we do to one side, we do to the other. So let's try that. So here I have 8 is greater than v minus 1. Well, right now, if I'm thinking of my inverse operations, I'm going to do the opposite. Well, right now with my v, I've got a -1. Well, what's the inverse of -1? Well, +1. So I'm going to follow all the same rules that I just did. I'm going to go ahead and carry down my greater than symbol. And 8 plus 1 on the left side is 9. And v minus 1, then plus 1, that gives me v plus 0, so I can just write v. So what I've really got is 9 is greater than v. But if you recall in our last lesson, it's easier to graph if we write the variable first. Okay, so I'm going to write the variable first, and right now the symbol is pointing toward the v, so I'm going to keep it pointing toward the v and say that 9 is greater than v. So if 9 is bigger than v, we can logically say that v must be smaller than 9. Okay, well now we're just back at graphing that like we did yesterday or the last time we met in class, and we know how to do that. Well, I'm going to find my focus number, which is 9, and I'm going to circle it. And then I have to decide, is it going to be open or closed? Well, I know when I'm graphing something equal to, it can be exactly that, and I close it up. But this doesn't have an equal to on the bottom, so I'm going to leave it open, and I'm going to go ahead and shade to the left, because I know that everything v is smaller than 9. So all the things smaller than 9 are my answer. And I'm going to include an arrow on the end, because it doesn't have to be visible on my graph. Like 0 is not on my number line, but I know that 0 is smaller than 9, so I have to include that arrow on the end. Okay, well now let's try it with the next one, because the next one looks a little different. It looks like a fraction. Sometimes fractions are scary, but we just need to remember that that fraction bar, that is the same, it's a fancy way of saying division, k divided by 6. So if I've got k, excuse me, divided by 6 is greater than or equal to -9, then I know the opposite or the inverse of divide by 6 is just times 6. So I'm going to times both sides by 6. Now on the left side, the 6's, they turn into 1's because 6 divided by 6 is 1. So they basically cancel each other out, but you know I don't love that word. But they eliminate each other, leaving me with just k on this side. And I'm going to carry down that symbol, greater than or equal to. And now I've got -9 times +6. Well, that's -54. My k is already on the left, so I'm just going to look at my focus number, which is -54. I'm going to circle that. And could it be exactly 54? Well, there is an equal sign on the bottom of that, so I know it could. So I'm going to shade in 54, because it could be 54, or it can be anything greater than 54. Okay, moving right along. -3 plus p is less than or equal to -17. Well, I don't want you to get tripped up by this plus here and think, well, I've got to minus it. Because what we're looking at is that -3. We want to do the inverse of -3, or taking 3 out of there. We're going to add 3 to both sides. I'm going to carry down my symbol, so I've still got less than or equal to. And on this side, these two turn into 0, so I've only got p. And on this side, -17 plus 3, well, 16, 15, 14, that's going to be -14. And if you don't remember the rule for that, you can always sing the song, same signs add and keep, different signs subtract. Well, this one's negative and this one's positive, so they're different signs. I subtract and I keep the sign of the larger number, then you'll be exact. So my variable is on the left side, which is what my the easiest way to spot how I'm going to shade. And my focus number is -14. So I'm going to go ahead, circle -14. And now I just have to figure out, well, is it going to be an open circle or a closed circle? Well, it can only be closed if it could include that exact number. And this one does have an equal sign in the bottom. So I can go ahead and close that circle. And p is less than that. So I'm going to go ahead and shade all the values where the numbers are less, or to the left. Again, for number 4, we've got that fancy division bar. It says v over 3, or v divided by 3. Well, the inverse of divide by 3 is to multiply by 3. I'm going to carry down that symbol so I don't forget it. On the right side, I've just got v. On the left side, I've got 18. So it says 18 is smaller than or equal to, less than or equal to v. But just to make it easier for me to graph, I'm going to go ahead and flip that around. So v, I see that it's pointing away from the v, so I'm going to keep it pointing away from the v. V is greater than or equal to 18. And that makes sense because if 18 is less than it, then we know it's bigger than that. So I'm going to go ahead and look at my focus number, which is 18. Okay. Do I need to open it or close it? Well, it can only be closed if it could be equal to it. And I see part of an equal sign there, so I'm going to go ahead and close it up. Say that V is greater than that. So V is everything that could be bigger. Anything that could be bigger than that. And you can always test and pick one of the numbers that you've shaded and see if that works. And if it does work, then you know that that's true. Okay? So pretty simple, right? There is a catch. So let's consider what happens when we try to multiply or divide by a negative number when solving an inequality. So here, everything that when we multiplied here, on number 3, we multiplied by a positive 6. And when we multiplied in number 4, we multiplied by a positive 3. But what happens when we try to multiply or divide by a negative when solving an inequality? So just think about that for 1 second. Maybe try a problem or two in your head. Press pause if you need to. I want you to write this down because this is important. So go ahead and write this down. Take a minute, press pause if you need to, but really think about this. When you multiply both sides by a negative value, you make the side that's greater have an even bigger negative number. So this actually means it's now less than the other side. So to show this, you flip the sign whenever you multiply or divide by a negative number. So it's not adding and subtracting. It's only when you multiply or divide by a negative number. So that means that coefficient, that number with the variable, when it's negative, you're going to end up flipping your sign. So if the number hanging out on the other side is negative, that's okay. But if the number that you're getting rid of is negative and you have to get rid of it by using multiplication or division, then we're creating something a little bit different and we have to flip the sign. So let's see how that looks. So here we've got 16 is greater than negative 4 times n. Well, I see that that negative 4 is attached to n by multiplication. So I want to undo that by using a divide by 4 and a divide by 4. Okay? Now, on the right side, I only have left n, and on the left side, I have negative 4, right? Because 16 divided by negative 4, well, a positive divided by a negative is negative. So now I'm going to test that. I'm going to go ahead and flip the sign. So it was greater than. Now I'm going to make it less than. So this is what I think my answer is. N is less than negative 4. I like to write it with the variable first, so I'm just going to say n, and it's pointing away from the n, so I'm going to point it away from the negative 4, which kind of makes it confusing because it looks like I flipped it back. But remember, I didn't. I just changed sides. So looking at this, let's see if it's true. I go to my n. Well, it says it's at negative 4. That's my number, so I'm going to circle it. And I don't see any part of an equal sign, so I'm going to go ahead and leave it open. And it says n's greater than all of those things, so I'm going to shade everything this way. Now, what that really means is that any number that this line is covering, all the way down in numbers I don't see because I covered the arrow, that's going to satisfy it and make it true. So let's just think about this. That means that negative 4, anything that's covered here is going to be true. So like 0 could be a number. So let's just plug that in and see. 16 is greater than negative 4 times 0. So if I did this right, this will be true. I'll have 16 on this side, and I'll have greater than, and then I'll have negative 4 times 0 is 0. Is 16 greater than 0? It is, so I know I shaded right. But what if I had shaded wrong? What if I had shaded wrong? What if I said, let's say, what if I picked this number right here? What if I picked negative 5? I'd have 16 is greater than negative 4 times negative 5. And I want to see, is that true? On the left side, I have 16. And on the right side, negative 4 times negative 5 is actually a positive 20. Is 16 greater than 20? It's not. So I know that this number that I was testing down here, this negative 5, is not true. So that just kind of proves to you that what I'm saying is legit. It works. So let's go ahead and try it again. So we've got negative 3p greater than or equal to 15. So I see that p has a coefficient of negative 3. And remember, a coefficient's a multiplier. So negative 3 times p. So I know that I have to divide by the negative 3. So even though that 15 is positive, it doesn't matter because the thing that I'm applying to both sides is negative and it's being manipulated with multiplication or division. So what I need to do is I need to flip that sign. So instead of greater than or equal to, it's now going to have to say less than or equal to. On the left side, I have p. And on the right side, 15, positive 15 divided by negative 3 is negative 5. So p is less than or equal to negative 5. Negative 5 is my focus, so I'm going to put my circle there. And if I see a part of an equal sign, which I do, I can fill it in. And this is saying p is anything less than this value. It can be that number, but also anything smaller than that number. And again, I can just test that. I could just plug in, let's see, negative 3 times, let's say negative 6. And see, we want to see, is that actually greater than or equal to 15? Well, negative 3 times negative 6 is a positive 18. Is that greater than or equal to 15? It is greater than 15, so that does indeed work. Now let's look at number 3. I'll even zoom in a little bit here. You can press pause if you need more time on the other one. But for this one, number 3, I've got negative 8 is greater than or equal to r divided by 6. So it looks a lot like the ones that we were doing, but this time we notice that r is divided by a positive 6. That negative 8 is on the other side. So the thing that we have to get rid of is the positive 6. So I'm going to take this times positive 6 and this times positive 6. Well, I know that I only need to flip that sign if I'm dividing by a negative, but I'm not. I'm not multiplying or dividing by a negative because the 6 is positive. So let's see, on the right side, I'm going to have just r. And on the left side, negative 8 times positive 6 is negative 48. Okay, so I know that that's my solution, but I'm going to rewrite it. And let's see, it's pointing toward the r, so I'm going to keep it pointing toward the r. Negative 48. So I'm going to find that focus number, which is negative 48. And r is less than that number, so I'm going to shade everything on the less that has a less value over here. And the arrow, can I close the circle? Well, it has a piece of an equal sign, so I can close the circle, so I'm going to do that. And you can always check and see, well, did that work? Is it true? So if you picked any number that corresponds with the shaded part, it will give you the right answer. So we're going to try again, one more time. Negative 5 times z is less than or equal to 45. Well, I see that my coefficient, my multiplier there, negative 5, is being multiplied to z. So to undo a multiplied, I'm going to divide by the thing I want to get rid of. What I do to one side, I have to do to the other. But now, instead of just carrying this down, this time I'm multiplying or dividing by a negative, because the -5 is the thing that's moving. So I want to, instead of making it a less than or equal to, I'm going to make it a greater than or equal to. So these go away, leaving me with just z. And on this side, positive 45 divided by -5 is -9. My variable is already on the left, so I'm going to leave it alone. My focus number is -9. Is it open or closed? Well, I see part of an equal sign, so I know it could be exactly this number. I'm going to close it. And it says that z is greater than that, so all the numbers to the right, all the numbers that are greater, including numbers I don't see. So I'm going to fill in the arrow on the end and all of that shading. So sometimes this rule doesn't intuitively make sense, but we'll talk about it in class and maybe we're going to do an exploration activity, if we haven't already, that helps us see that that is true. So recap, when dealing with inequalities, so we're talking about inequalities, a negative with a variable means you should flip the inequality symbol. So when you're dealing with an inequality, if you're moving around any positive number, whether you're adding, subtracting, multiplying, or dividing, you're fine. Just keep it the way it is. But if you are multiplying or dividing by a negative, then you must flip the inequality symbol for it to hold. Here I have 4 practice problems that just deal with positive numbers. Nothing, just get used to treating it the way you would solve normally. But then I have 4 more that you might have to multiply or divide by a negative number. So you have to pay attention to see, do I flip the symbol or not? So these do not need to be submitted to me, but you still have to do them. That's how you get the practice to understand that you're ready to move on to the choice board, or that maybe, hey, you need Wit to come and explain it again or in a different way, or to help you through it.